actually. It means I started recording. Okay, so now we are practicing, we are almost like becoming an expert actually. So. Certain things I observed actually, so from what you were testing actually. So, but anyway, you are learning it actually. So you are correcting yourself. Actually, this is what conversation that happened with so Rajgopal and Sendil is there actually. So I told them this is what I will go through. So C hello world, C++ hello world, Win32 sample program, MFC library creation and DLL creation actually. So at last you will have a assignment like I told you already. I told you. So you just create 5 times libraries with whatever test program that you are working with. We can test it also in a library 5 times and DLL 5 times. So with that you will know how exactly this library and DLL can be created, and then we will jump into pointers. So actually this is the reason for that actually. So you will come to know about the Visual Studio environment, and finally today I will be telling you about the difference between library and DLL. So you will come to know how Windows OS is structured, and you also know how to debug. This is what actually we discussed. Since you already know Java, so you will be knowing this class and inheritance. So that's why you can learn that one by yourself. So, I think there's a multiple inheritance, and there's one more thing is there in inheritance, multiple inheritance.
Hybrid inheritance.
Yes, I'm saying it's called runtime binding actually. It's new. It is related to pointers. So that's why I said C++ object pointers. So see, you know already. You must have worked with pointers. So you know already a few things about pointers. When we deal with class object pointers, it's same thing, but there's something called runtime binding actually. So it is I will explain you, but you will know actually what is that. So mostly these things are all to introduce you to the environment actually. So how to program. So this is the desktop, creating the desktop application using C++. So you can use C#, then .NET, but they will be little different. These things will help you to create with a more control actually. It will give you more control over your application and over the OS. So using the C++, and you can use any of the functions, C function, C++ function, Win32 functions. Sandhya asked what is the difference and what to use, and I told her you can use anything at any time. Most of the I think some of the functions in C++, they indirectly call Win32 sample with that in Win32 APIs. internally they call actually. So they are wrapper functions. So instead of using IO stream or a file, I can directly call while creating the file we can use create file actually. There are even more advanced topics like threads and synchronization. You might have studied about semaphores, events, mutex in your college. Have you studied semaphores? It will come. You might have studied, right? Semaphores, mutex. Yeah, you have a paper with called operating system, right? So you might have come across actually semaphores.
Event handling function. Event handling.
Yes, event, mutex.
Mutex event handling.
Yes. So semaphores, they're all. That is totally different actually. So I don't know. I will cover those things, but if you want me to cover later on, if we have time, we can have some session on that one. And last recording was muted. I don't know. There is a loose connection here actually. So I think that's why it got muted. But anyway, you understood, right? That video actually. So and the program which I show you all these things, sample programs, right? When you go into production, when you start working with the projects, it won't be as what you do, but the concept is same. It will be little different, but the concept remains the same. So don't expect what I did will be available, the same code will be available in your project. It will be little different actually. So but concept remains the same. So to make you understand the concept only, I have written like that actually. And today actually DLL creation, like Pawan knows how to export structure actually, right? And I also told you about how actually we define export and import actually. So if you have time, I will just show you, but first I will explain you what is the difference between library and DL. I will just show you actually. So mostly we won't be using Visual Studio actually. I will be showing you using MS Paint. I will be trying to show you. You can copy this in your mobile and you can watch it in your home also, but don't share it, because you see many things are there actually, mail, code, and so normally company doesn't wants to know other people's outside the company. They don't want to make this thing visible to them actually. So you yourself use it. And I am teaching you in such a way that I am so that you yourself can learn actually. That's what my intention. Actually, I don't want to teach a specific thing, so like what you are studying, template, like arrays. I don't want to, but I am just trying to teach you so that you yourself can learn it. Whatever subject you wanted to learn actually. So the concepts. So I think last Thursday or Friday actually I was explaining Kishore about this diagram actually, so related to this diagram. So did you try to understand this one? Oh, he told you, right? So that is the project dependencies. Okay, so I will not go to this. Okay, so what is the difference between library and DLL? So both are libraries. Okay, I will just explain you in pictures, then you can understand easily. So already you were searching what is DLL, right? So did you get it? Able to understand? Oh, no problem. Okay. So suppose you have a disk. Now you imagine in your hard disk like you created some libraries. So maybe let's say lib1, and you have a function, a library function, maybe add. Okay. Internally, when you compile, it gets library gets created. So internally the library will contain the function and the binary code. So something like this. Okay. So each library, whatever library you are adding, that will be created like this. Internally, it will be represented as a binary code, but it won't run actually. It won't execute. So in order to execute, you need to have a executable exe. So okay. Now you have another. Maybe a console application. Say we have the same disk. So you have a application test lib. Okay. You are writing the w main, okay, and you are going to call add and subtract like this. So what exactly it happens is, when you compile this test library, it generates a exe. So it generates a exe. I don't think like internally it is represented the same way as I am showing here, but it will be little different. Just for your explanation, I am just telling. So whenever you call, so you are calling add. Suppose if you are calling add maybe so something else like this. What happens is, when you, this also contains some binary. Okay, it contains some binary. So you are calling this add function from lib1 actually. So we'll just add here from lib1. Okay. What happens is when you are trying to compile, when you are trying to build this exe, all the binaries from this add will get added here. So 1 0 1 0 0 1 0 1 0 1 0 1 something like this. Okay, and same way we are calling this up from the lib1, and here also it gets added 0 0 1 1 1 0 1 0 0 0 1 0 1 something like that. So this is how your exe looks actually. So when you double click, your double main get called, and add gets called, and suppose you have a you are just double clicking this exe, the whole program, that is the whole binary, gets loaded into the your processor. It means in your RAM memory, the whole thing will get loaded. So all will contain all the binaries, whatever it is, 1 0 0 0. So whatever you build it gets loaded here, and it starts executing it. So once if you compile, that's it. Your exe is enough. There is no need for you to move a library with the exe. So after compilation, the library gets like it is no more used actually. So because all the functions that you call from the library gets included into the exe also. You understood, right? So that's why library is used only at the time of compilation. So after you finish compilation, you just deploy the exe or run the exe, and everything gets loaded and it starts executing. Okay. Now the same thing. Suppose if you have another project, and you write some another application, some test lib.exe. Okay, so there you call maybe so this is the Windows application, and you call maybe sub from lib1. So again what happens is it do the same thing actually. So all the binary get included, and the binary for lib sub also will get included. That is 0 0 1 1 1 0 1 0 0 0 1 0 1 dot so something like this, and everywhere 0 0. So it will get included. So once if you compile, there is no need for you to have the lib with the exe. This becomes independent. It will just get included into your application. And once if you double click this exe, So everything gets loaded as it got loaded in for this test library, and it will start executing actually for you. So you keep this in mind. So the size of this exe, the size of exe is also is size of the exe plus its lib1. So not all the whatever the functions you can only get included, not all the function will not get included. So part of the part of lib1. So that so the size will be little large actually, because you also included some of the function from library one. Same way the size will be like some of the code in WinMain, and then whatever the function you call, that gets added, so the size keeps increasing actually based upon the number of functions you call actually. So this is what happens in library.lib. Okay. You just keep this in mind. You understood, right? Any doubt? Okay, now let's go to DLL. So imagine you have a DLL1, something like that. So you saw that while creating a DLL application, library and DLL gets created, right? You know, right? You both. So let's see what. So let's see what happens in to library. First I'll show you the DLL. So DLL1, we have DLL main, and so you added a function, you just wrote the function add, and then the binary will be there here. Sub. Okay. So even DLL also contain the same thing as a library. But in the case of DLL, we saw that a library also gets generated. So we see, like in this library, we see what it contains. So we'll have a lib1. Okay. In the lib1, there will be two functions. Add. Okay. And then it contains sub. Here it won't contain binaries. Instead, what it will have, there will be some code. What it will say is, I will draw the diagram. So So I said the two things will get created, DLL and library. So DLL contains the same thing as the library is there, right? So add and sub and their corresponding modules, so whatever you write the code. But in the case of library, I mean that .lib which gets generated while building the DLL, it contains only the link. That library says all the functions of add and sub is referred in this in this DLL1, and the function is available at this location, and this function is available at this location. It contains only the reference. Maybe I will add it. So only the reference. It doesn't contain. Suppose if this add is maybe 2k of code, actually binary code, this will contain only few pointers saying that few bytes of code that tells you that the actual code is somewhere else in another DLL. That's all. That's it. So it contains the reference. Okay. It doesn't contain actual code, 2k of code. It only few bytes that will indirectly link. It will be pointing to this binary in the DLL. So now we'll see how it gets executed when you compile it with your test application. So we'll create a project. So and then we okay. You have a test DLL 1. Okay, there you will be having W main. Okay. So some binary. Now imagine you are going to call add from lib1. This lib1 is this one actually, okay. And then you have some other binary. That's it. So what happens is, you know what is library actually. Whatever the library code, binary code is there, that gets included into in your test application, right? So same thing happens here also. Okay. So we are calling add from the lib1 actually. Okay. So whatever the code is available in the lib1, that gets added here. So what indirectly it happens is, the code contains some reference to this DLL. Okay. So indirectly when you compile, when this reference code, actually this reference code also gets added, it will indirectly link it. So just okay. So that means the library, the function which we call add from lib1, the whole code gets added into this test test application. So indirectly it will also link this add function to this DLL. So that's what it happened. That's when you compile. Okay. So next what happens? Now let's see what it happens at the time of processing. So we'll have the memory here. So imagine this RAM memory, and you are just double clicking this test application. The entire thing gets loaded. So I'll just add the process. So the whole code actually maybe was something. And it's also reference to DLL1 because we compiled it with library 1. So this also contains reference to DLL1 actually, which is nothing but add. Okay, and then some more code. Okay, so what happens is this gets loaded into the processor and it starts executing. So whenever it sees this function need to be called add from DLL1, there is no code, actual code is not there. Actual code is available here, right? This library add code is just contain a reference actually. This will only refer to this function, but the actual code module which you created a function which will do some processing like printing tree or some array manipulation or something with vectors you are doing, right? It contains here. So this is not yet in the memory actually, this is just in the disk. So whenever it come across this reference to add DLL gets called, what happens is this whole DLL, let me whole DLL, maybe I'll add here. Imagine this is also the process space, the same process space actually. I just put it in a separate location. So it's a RAM memory. So the whole DLL maybe I'll just copy this up. This gets loaded into the processor. So only at the time when you call add actually, when this function gets called in your program, suddenly what happens, this particular DLL, it notes its reference actually. It will know how, where is the reference. So it will, all the code needed for this function gets loaded actually. Okay, so maybe we'll add an arrow here. Okay, so when this add function is called, immediately what happens, this particular DLL gets loaded into this process space, and immediately it will be jumping to this location, to this add location. It will start executing this line with this particular code module, and it will return, and it will start executing the rest of the modules. So this is what it happens. So what is the benefit actually? So now the actual benefit I'll tell you. So now suppose you have another project, okay, you have another project, and you are maybe a small project. Maybe I will copy this whole thing. Instead of DLL1, I will just say it is DLL2. Maybe I will overwrite, try to overwrite. Two. Okay. So DLL2. So something like this, where I am calling this add, and this also contains the reference to the same particular DLL. Same DLL. Okay. So this is the second project, and when I try to run this particular application, a console application, this gets loaded into the memory the same way as the first one. We will just copy paste. So this also gets loaded here. The same, means it's not the same program. I just copy paste. Okay, I just double click this DLL test DLL2, and this gets loaded here, and it start executing this code actually. So this binary code gets executed, and at the time when it sees the processor sees this reference to DLL. Okay, what happens is, immediately okay, here's where you need to be very careful. You try to understand. Immediately at the time when you call, when the reference to a DLL to add function gets called, what happens is this particular function is already loaded actually. Immediately it will go and jump to that location. So here I'll just add okay. You see, this DLL module is being shared across two processes. Understand? So in this case you have two projects, testlib.exe and some testlib.exe. You try to you build a library with add and sub. When you compile, this particular add and this particular sub gets added to this executable, and when you try to execute, it gets loaded here, okay, in a separate process. Suppose even the same thing, I'll just copy paste. This is some testlib.exe. Okay. And this some test.lib, the whole program gets loaded and it starts running, executing. You see, the library is not getting shared actually. So there is a code for this library here, and there is another code for this. The same library gets loaded in another process also, right? But here, in the case of DLL, the same function here in this library, the same function add gets loaded twice, here and here. Okay, but in this case, when you call the function add, the two different processes, the same function gets loaded once here. Okay, this is the this is the difference. This is only the difference actually. So if you see most of the Windows operating system files will be mostly DLLs. Windows you see most of them are DLLs actually. So if operating system is a huge program, right, it will manage your hardware. So if operating system start building with a library case, the whole operating system will be like very huge actually. So you should have like large amount of RAM memory actually. So in order to avoid that, the operating system they try to build it as a DLL. So that even though it gets loaded by different process, it sees that it gets shared actually. Okay, it's shared, but the data will not get confused. The data used by add here and the data used by add here are different. That's what you should keep in mind. They remain separate. That never gets combined here. So all those things will get managed by the operating system. So that's why like OS also is built mostly by DLLs. So because the OS is very huge, and if you try to build with like a library kind of thing, it becomes the OS, entire OS becomes very huge, and you need to have a very huge like RAM memory and all those things. So in order to cut short those things, they build it with the DL concept. Okay, so this is just a basic, but you will be learning even much more than these things. One more thing, okay, suppose this particular library and DLL, somebody found some mistake in this add actually. Somebody found some security patch or some mistake, some kind of bugs they have found. What the company will do, they will go and fix this particular add. They will go and fix this particular add, and they will deploy this DLL alone. They deploy this DLL alone into your operating system. So when you give updates, the DLL gets updated. If same thing is there, if they had built your application using library, suppose if somebody found some mistake in add, they have to deploy the entire exe. You see that, right? So instead of deploying the entire exe, they built in modules as a DLL so that we can easily patch and fix. So, and that too, this DLL gets loaded only when you call it actually, and otherwise it won't get loaded actually. So in this case, not like that. The entire program gets loaded actually. So, and then it gets, so it's a kind of memory management actually. So for this purpose, like for certain things are library, but mostly the OS all are dependent on DLLs. And if you have built our executable as a library, the executable also becomes very huge actually, and it will be I'm not sure, it will be difficult to manage actually. So we cannot give patch easily. But in this case, in this case, there will be like thousands of DLLs. You just need to fix certain DLLs where errors are there, bugs are there, and deploy the DLL alone. So that's it. So that's the difference between library and DLL. You understood, right? So maybe I'll, but what I showed you is not exactly what it represented in actual OS, just for your understanding. for your reference only I just sent it. Okay. Normally actually I added one function here, add. Suppose I want to add more functions, so you can copy paste. Okay, like this. Okay, you can copy paste. But the disadvantage is, like, if you have hundreds of function, 2 times you need to get included. Okay, so normally people won't do like that actually. So I just told Kishore like how to do it. I don't know whether I need to explain you, or it will be little confusing for you, but I think you understood, right?
Yes.
Maybe you can later on, because most of your projects doesn't have like this actually. It will have a different way. Maybe I sent a screenshot from Pawan's machine.
So I sent this group only.
You sent it, okay. But see, we don't have okay. Maybe I'll explain you. What we do is, we have one single function int add. So int ni. So int nj. Instead, what we do is, we just remove this thing, and that extra function we will define actually hash whenever we define a macro, we need to give some name actually. Okay, so hash define, maybe this is the either import, is either export or import. So I'll write so you just need to include this statement here. That's it. It means the same thing. Here you are defining this macro with this value, that is declare specification or DLL export or declare import. Okay, and then you include this macro here. So this macro, it can be, it means two things. Either it is DLL export add or DLL import add. Okay. So how we have to modify in other place? So we added here, and rest of the thing remains the same thing. So no change. So suppose you are adding more function, you just here maybe sub. Okay, you see the green, sometimes it just a warning actually, so that's why the green color underline is come actually. So you just see that there is a declaration. I have only declared it, but I didn't define it. So here I have defined for add, so same thing for I have to do for sub. So sub, okay. Now still it has not changed this. it is still underlined, is coming like a green color mark, even though I defined. Can you tell me the mistake?
Yes, it's marked.
Yeah, same mistake which Sandhya also did. So here it is sub, so it should case sensitive is there. So I think now the underline, the green color mark is gone. If red color mark is there, means like it will tell you that error is there. So it will also appear in this scroll bar as a red color mark. Sometimes you will be having both the declaration and definition, but still some underline, green color underline will appear. But it is like a warning actually, some kind of warning. You can just ignore those things. So normally in your project you will be seeing your code like this. And one more thing is, normally you won't see this definition actually, this particular definition in your code. Instead what they will do is, I will just comment this one. They will go here, go to project properties, C++ preprocessor, they will define it here. So for all configuration that needs to be defined actually. So like this. So I just define for debug and x64. So if I go into this header, export is enabled. Same way, I remove the definition. But I have defined it in the settings, project settings. Okay. Same way here, we won't define it here. So automatically the else part will be considered. So it's a DLL import actually. So normally people they will define the macro in this preprocessor settings. Sometimes they won't declare. So it depends upon your situation actually. So you will come to know about that actually. So normally they used to define your hash define settings here. So if it is not declared in your file, you just go and see at this place. There will be some declaration will be there. I'll just remove it. I'll add it here. Since I included header once in this project, that's why I just declare it once here. Suppose if I have a very large project, like a huge number of files where I have to include this header, so each time I include the header, each time I have to define it, and sometimes you will be getting some error like already defined, like that some warning or error message will come. So in that case, you just don't have to declare here. You just add it into the preprocessor settings. Project, you know, right? So in the project properties, preprocessor and preprocessor definition, you just change it for all configuration. So that's it about this library and DL. So and try to do like 5 times library and 5 times DLL, like as usual with what we are trying. Today Pawan faced one issue like structure, right? I just showed you how to export a function, but he wants to export a structure actually. So that was like new thing actually. So that also the same thing, like because he wanted to use not here actually. He wanted to use a structure not here. He wanted to use the structure here, which is exported from this DLL. So he wanted. So the same way you can, whatever you declare and define, you just add this export macro. So export and import macro. So everybody understood, right? So You just keep this in mind, the difference between library and DLL. Now you know actually, so why we use library and why we use DLL. So just for your understanding, that one. So you have any doubts there? And you know how to debug, right? F9, F10, F11, shift F11. Also you try, keep in mind debugging with attached to process. That also you must keep in mind actually, because you will not be writing your console application, you will not be writing your executable. You will be using some others CAD application, like so where you cannot debug like normal way. You will be running your CAD application, your DLL gets loaded, and then you have to attach your process to that particular CAD application. So that is the one thing. So I'll just quickly show you. Suppose I'll just add one message box. I build it. Now I will just try to execute. So well, it's a release. Okay, I put it in debug. So you consider this application is a CAD application. Okay, now you need to attach to this process. So you know, like somewhere your message box has popped up in your CAD application, and we just put a breakpoint here. Now we just go and attach to the process. So your process is here and the message box is here. If you see your process, this is the process, right? testdl.exe. So you will know your process has one ID will be there. So 83252. So the process name is testdll.exe. Just go to your project. See that this remains active actually, startup project. Okay, you will be facing problems like Sandhya, right? She was trying to her project was active in the DLL, and she was seeing this code, and she was running Control F5 by looking at this code. So it showed some error because it is trying to execute this project, not this project. So because this DLL library is active, so it's trying to execute. So just see that this one is active, and then you just go and attach to the process. These are all like local, actually local. Most of the time, in my case, my application will be running in a remote place. I have to sit here and debug. So that is called remote debugging. But you don't have to go to that one. But that's a very nice technique actually, how to remotely connect to a process and debug actually. That one maybe later on after after you start your project, you can learn it later on when you are free time. So by default, see that this native code is there. Okay, and you just search for your application. So you can search with this ID or your name. I think this one, right? Just DLL, just attach. So see that it gets highlighted, means the red color mark appear actually. Sometimes the red color mark won't appear, means the code is modified or you didn't attach to a proper process. So for example, I'll just maybe it is not changing. Now I'll try to attach. First I will detach, stop debugging. Maybe I'll add some, modify the code. I am just not building anything, I am trying to attach. Okay, it stopped running. I will run this one. I didn't compile, I just executing the previous executable. Okay, now I modified the code, I didn't compile. I will refresh here. Now the process will come here. Test DLL. You see it's not highlighted. It means my code and the executable doesn't match. So the executable, you know that it has 100 actually, 100 comma 200, but I changed it here to 1200. So you just see that it matches, this red color is highlighted. So just to show you, I just did this one. Now I'll build it. I'll just execute and then I will attach. You see, it's the full red color dot is there actually. Means your code and the program that is running gets matched. So that's why it's now you just click OK here. As soon as finishes, this message box gets finished, your report stops at this breakpoint, and then you, as usual, you can normally you can debug. That's all. Apart from your normal debugging, F9, F10, F11 and Shift F11, keep in mind this attached to process also is there actually. Okay. Next will be like I'll teach you like not the complete pointers. I will be representing the pointers, how to view the pointers at the process level actually, so that whenever you study about the pointers, you will come to know like how exactly you can easily understand actually. So I will just explain you pictorially how to see pointers in the process. It's fine, right? Do you know the in Java you might have studied about the variable scope of the variables. You didn't study anything like that. For example, if you have Do you know like how long this variable will be there in the memory? That's called scope of the variable. Like what is the scope? What is the visibility of this variable? Actually, we call it that way. You might have studied, right?
Within the block.
Ah, yes.
Local.
Ah, yes, local. You might have studied, right? Okay. So you already know that. So I'll just try to explain how to look this one in the process level actually. So after this only I can go into pointers. So that is the building at the base level. I'll just start it actually about the pointers. So called local and global variable. Like, so that is the scope of the variables actually. Okay. So anything else I left? Anything? Any doubt I have? So mostly I covered all the environment related things, so that it will be easy for you to study. Actually, pick up whatever you are studying, you can easily pick up and then go ahead. So always try to debug actually, so that you can easily fix the problems. But sometimes some unwanted problems you also faced, like last week problems will occur because we didn't configure the setting. Like today you faced, right? The path was like you gave the wrong path actually. So those problems will occur. That will your development process will get hampered actually. So see that you don't get entangled in those related problems. You have to face some other problems, some valid problems related to your development actually. So see that you don't get trapped into your environment related problem. That will waste your time actually. So this is not the time for you to. So you just follow the rules actually. Just try to change accordingly. And focus on your development actually. So, and as I said, you just try 5 times library and 5 times you try DLL. So that will get fixed in your mind actually. One more thing, this is not the only way to create a DLL. So there is another way actually. Initially, that's the way I learned it actually. So, but I will not cover those things. That's not needed. Usually there is something called component object model. Have you studied about component object model? So most of the DLLs are COM DLLs in Windows. So they define like that is the way we create DLL for developing a component object model. So some of the DLLs you won't find this declare specification, export and import. There will be something else like def files. There will be something called, instead of this additionally there will be something .def file, .def file. So that I will not cover anyway. I will not cover this thing. So there are some methods which I didn't teach you. You just maybe you will come across those things. Suppose if you are working on some project, means if you are not able to understand some modules, means what you can do is you can try out those particular modules in a separate console application, so that you will try to understand what exactly the module is doing actually. So you understood what I said? Suppose this is the project I have. Suppose you see something like this. Maybe some Okay, these are the commented code. Suppose if you happen to see something like this, so you wanted to know exactly what this code will be doing. You just what you do, you don't know what this function will do. You wanted to know what this particular parameters, what it means. So you just wanted to know what are all this function will do. So in that case, what you can do, you create a separate console application, and you just type this create file and with the exact parameter, maybe with a different file location. So try to do, and you will come to know like, okay, this will trying to create a file, and it is trying to do something with like end of file, and it is trying to set the file pointer something. So you have to understand your project, you have to understand the code module. Sometimes you have to try out separately, and then you have to come to your project. So certain things you cannot try actually. For example, we have this function. So this function model, you have to include a lot of libraries, and so DLLs, it depends upon some DLLs and libraries. So you cannot try all those things. In that case, you can ask some people actually. But most of the thing you can try certain things by in a separate console application. So because all the libraries, Windows libraries are available. So okay. Maybe next tomorrow I will start with the scope of the variables, and we'll see how it, and then we'll jump into pointers. Fine, right? I'll just stop the recording.